Hi, welcome to my course on exceptions in Python programming language. In this course, I will cover the topic of exceptions in its entirety. Before we get into practical examples in regards to exceptions, here's the general information you should know about exceptions in Python programming language. When an error occurs in our code, the program will stop automatically. Data will be created called an exception. These activities are often referred to as raising an exception. When Python has no idea what to do with your code, it raises an exception. If we do not take care of the raise exception, the program will be terminated, and you will see an error message displayed in your console by Python. If we handle the exception, the program can be resumed and its execution will continue. Python offers effective tools that allow us to observe exceptions, identify them, and later handle them. Each potential exception can be identified by its name, so we can easily categorize and react accordingly. Here we have a practical example of an exception being raised. So we have the following code: a variable called data, to which we will assign an integer of 1. Then in the second line, we will use the same variable called data, and we will try to divide the data variable, which contains an integer of 1, by integer of 0. As a result, we will have the following error displayed in our console. Traceback, most recent call last, file, this is the name of our Python file, div.py, line 2, which refers to the second line of our code, data, here the division plus the assignment operator, so shortcut operator has been used to divide the following variable by 0. However, it's not possible to divide an integer of 1 by integer 0. Therefore, we will have an exception called zero division error raised by Python programming language. Now, the zero division error is one of the most common exceptions in Python programming language and is usually being raised when a division is performed when we try to divide an integer of 1 by integer of 0. Then moving forward, here we have another exception. It is also well known and is very popular among the exceptions. It's called index 0. So here we have the following line of code: list, to which we will assign a list variable. We have assigned an empty list data type to our list variable. Then we use the x variable, assignment operator, and we will try to access our list variable at index 0. Therefore, we will have also an error displayed in our console: traceback, more recent call, file, the name of the file, line 2, which refers to this specific second line of our code, list, indexing, index error, list index out of range. So when there is a error in regards to indexing in our code, we should expect index error to be raised in Python programming language. When you run an incorrect code, you will get error displayed on your screen. For example, if you try to add an integer value to a string value, you will get an error message displayed on your screen, such as, for example, concatenation is not possible with a string value to add to an integer value. For that not to happen, for the code not to be terminated, there is a try and except block ready to handle such exception. And for every type of error, there's a specific exception ready to handle it. So below we have an example of try and except block, which consists of both our keywords. And for example, inside the try block, we will place a variable of a, which now stores a string of 7, and we will try to add an integer to a string of 7. And we will print the following result. Now, the following code is of course an error. So it will automatically go to the except block, and instead of having an error displayed on our screen, such as concatenation is not possible, etc., we will handle it, and we will have cannot add a string to an integer text displayed on our screen. So again, we have try and except block. With the try and except block, we are able to handle an exception. We can use multiple except blocks in our code if we wish to handle more than one exception, and are anticipating our code to raise an exception different to the one the first except block was placed to handle. as the practical example here suggests. Inside our try block, we will place the following line of code. With the help of the input function, we will ask the user to enter a number. The data will be assigned and stored in a variable called n. Then we will try to divide the data stored in an n variable by integer of 1 and store the result of a division in a variable called y. And finally, the print function should display the data stored in y variable. We will use the first except block to handle an exception related to zero division error. And we will have the print function display the following message in our console. You cannot divide by 0. Sorry. The second except block will handle type error related exception. And the print function will display type error has occurred in our console. As we run the following code, the zero division error exception won't be able to handle the exception raised in our try block, as the data received by the input function is transformed into a string data type. Therefore, a division will not occur. So the type error exception is there to handle such exception. As a result, we will have type error has occurred displayed in our console. Also, if you press Ctrl+C while the program is waiting for the user's input, specifically when the input function occurs, and we press Ctrl+C while the program is running, an exception named keyboard interrupt exception error will appear in your console. There are 63 built-in exceptions that exist in Python programming language. It's a tree-shaped hierarchy. There are two categories of exceptions: concrete exceptions and general exceptions. Exception located closer to the root can be considered more general. General exception can easily handle an exception raised as long as it matches the coverage, and a concrete exception is not required. To demonstrate that, we will use the following practical example and showcase the results. Within our function, we will try to perform division. We will utilize the try except block to invoke the function and have the arithmetic error exception handle any possible exception relating to zero division. When we run the following code, we will invoke the function inside the try block by placing an integer of 0 inside the parentheses. As a result, a zero division error will be raised. However, as I've stated initially, a general exception of arithmetic error, which is a general exception, will easily handle such an exception as it fits its designation. So we will have exception was raised displayed in our console with the help of the print function. The raise instruction raises a specified exception as if it was raised in a normal, natural way. So here we have an example of us creating a function called division, empty parentheses, then colon, then inside our function using the raise keyword to raise the zero division error. So by using the raise keyword, we will raise the zero division error ourselves. So instead of letting Python to determine whether to raise an error after reviewing a specified code, we will raise the zero division error ourselves explicitly by using the raise keyword. Then we will use the try except block. So inside the try statement, we will invoke our division function. By invoking our division function, the zero division error will be raised thanks to the raise keyword. Then we have the except statement. Next to our except statement, we will place the arithmetic error. So arithmetic error should be able to handle the zero division error. As a result, the print function will display error in our console. Now, if we are unable to handle the specified zero division error, of course, Python will terminate the code in a natural way. So this is how the raise keyword can be used with exceptions in Python programming language. The raise instruction may also be utilized in the following way. Inside our code, here we have an empty raise instruction. An absence of an exception name. It is possible to use the raise instruction in the following way. However, it has to be placed in exception branch only. If we are to put it anywhere else, we should expect an error to be displayed in our console. One more important note, we can distribute the exception handling among different parts of the code. So inside our function, we have the try except block, and outside our function, we can also have a try except block. Now, we have the following function here. Def division, inside the parentheses, we have the end parameter, then we have the try except statement. Inside the try statement, we have the return keyword, and divided by 0, and parameter will be divided by 0. In case an error occurs, we have the except block here, print function. Inside the print function, we have the error string data type as an argument, and here we have the empty raise instruction. Then outside our function, we have the try statement again, try except statement. Then inside our try statement, we will invoke our function called division by placing integer 1 as an argument. In case an error occurs, we have the except block here, except arithmetic error. So we should expect the arithmetic error to handle this specific exception. Then we have the print function. Inside print function, we have the not okay string data type as an argument. So first, we'll invoke our function called division by placing integer 1 as an argument. It will go to our function. The try statement will try to divide the end parameter, which contains integer of 1 by integer of 0. Of course, an error occurs, error will be raised. Except block should be able to handle it, so we will have error displayed in our console. Then we will use the raise empty instruction. The raise instruction, since 0 division error has been raised, as we have tried to divide 1 by 0, the raise empty instruction will raise the 0 division one more time. Then here, outside our function, the except block should be able to handle it by the arithmetic error. Therefore, we will have not okay displayed in our console. So this is how we can use the empty raise instruction and also distribute the exception handling among different parts of our code by placing the try except block inside our function as well the try except block outside our function. In case an error occurs inside our function, we can handle it by try except block, which has been placed outside. Now we will use an instruction called assert. So we have the following line of code. First, we will import a module called math. Then we have data equal to float function, the input function, the inside the parentheses, a string data type of enter a number. So we will ask the user to enter a number. Then the received data will be transformed to float data type by using the float function, and the result of the following line of code will be placed inside our variable called data. Then we will use the assert instruction. So we have assert data, the greater than or equal to operator, and the float data type of 2.0. So you can think of the assert instruction as a conditional statement. We use the assert instruction to be absolutely safe from the wrong data, and when you are not specifically sure that the data has been carefully examined by a programmer. And assertion itself is there to assist an exception. So how can we use the assert expression? So when we run this specific code here and enter a number will appear in our console. If we are to type an integer of 4, the float function will transform the integer value into a float data type. Then it will move to this line of code. Then the assert instruction will make sure that the following data variable, which now contains a float data type 4.0, is greater than 2.0 or equals to a float data type 2.0. If the assert instruction is correct, it will move to this line of code. So we will get a square root of 4. As a result, we will have 2.0 displayed in our console. Now, if we were to place, when the enter number appear in our console, an integer of 1, for example, and the float data type, float function will transform it to a float data type 1.0. Of course, it's not greater or equal to a float data type of 2.0. As a result, we will have assertion error displayed in our console. So again, the assertion error the assertion instruction, can be used as a conditional statement inside our code. And again, when we are not absolutely sure that the data has been carefully examined by a programmer, for example, if we are to receive a specific code, we can place the assert instruction inside that code to make sure there is no errors in any of the line of the code. There is another branch which we can place alongside the try except block. It's the else statement. The else branch will only be executed in case of a code successfully passing through the try block. The else branch has to be placed after the except block. Please remember that. Now, through the practical example, I will demonstrate the workings of the else branch. When we invoke the access function by placing the following line of code, the val parameter will receive integer 0. We will go to the try block, create a list data type containing 3 elements, and assign it to a variable called element. Then we will use indexing to access an element at index 0. As a result, our code will reach the else branch, and we will have success appear in our console as well as integer 0 with the help of the return keyword. We will invoke the function one more time by assigning integer 5 to the val parameter this time. We will again reach the try block, create a list data type, and we'll try to access an element at the index 5. As a result, an exception will be raised, specifically index error. Our code will move to the except block, where we will have index error appear in our console, as well as integer 5, as we have used the print function and the return keyword. Our code will stop here. It will not reach the else branch. So this is how the else statement can be integrated with our try except block. And the else statement can be referred to as an else branch. We can extend our try except block by adding another branch called finally. Finally block must always be the last branch of the try except block. We don't have to place both else and finally branch within our try except block. It can be either one of them or both. And most importantly, the finally block is always executed regardless of the result. Now let me try to demonstrate the capabilities of the finally block through this practical example. As you can see, our access function contains the try except block as well as the else and finally block. When we first invoke the function inside the try block, a list data type will be created, as well as indexing will be performed successfully. Therefore, we will reach the else branch as well as the finally block. So we will have success and integer 0 displayed in our console through the else branch. An always executed message will appear in our console thanks to the finally block. Now we will invoke our access function by writing the following line of code. As a result, after the creation of a list data type inside the try block, an exception will be raised, specifically an index error, due to out-of-range indexing as integer 5 was assigned to val parameter. So our code will move to the except block, where we will handle the exception, and we'll have index error appear in our console as well as integer 5. Our code will skip the else branch. It will reach the finally block, which will display always executed in our console. So as you can see, the finally block is always executed regardless. Exceptions are actual classes. When an exception is raised, an object of the class is instantiated, so an object is being created, and the code goes through all levels of program execution, looking and searching for the adequate except branch that is prepared to deal with a specific exception. Exception as an object carries useful information, and in order for us to access an exception object, we have to catch the object using the as keyword. Then give the object an identifier such as an alias. I will use this practical example to show how it works. A list data type will be created inside the try block, as well as incorrect indexing will be used to raise an exception. Therefore, we will move to the except block, where we will handle the raised exception and capture it by using the as keyword as an object. As you can see, we have given an alias of index to our captured exception object. When we reach the print function and place the index inside the parentheses of the print function as an argument, a message of list index out of range will appear in our console, which is of course the reason behind the exception. The second print function will also display the same message in our console, as we have used the str method. By applying the str method on our exception object, we should receive a message in human readable form describing the cause behind the exception. So again, this is how we can capture an exception as an object using the as keyword, and of course, an important note, every exception is a class. The base exception class has a property called args. Args property is a tuple. It gathers all arguments passed to the class constructor. It is empty, of course, if we do not pass any arguments to the constructor. In the following practical example, we will create a function called display and equip it with few lines of code. Then we will utilize the try except block to demonstrate the functionalities of the args property. Inside the try block, we will raise an exception and pass an argument to the exception class constructor, a string data type of IM. As we move to the except block, we will handle the raised exception and capture it as an object by giving it an alias of EX. As we have used the exception class in our case, as the exception class is a subclass of the base exception class, it will also inherit the args property. So the exception class does also contain the args property. Using the print function, we will print the object itself first. Then we will apply the str method to the object. We will use the sep keyword to separate two objects with colon. As a result, we will get IM displayed in our console, separated by a colon. We will also use the end keyword to end it with a colon. Finally, we will invoke the display function by placing the following line of code, ex.args. As a result, values collected by the args property will be assigned to the element parameter. First, we will check the length of the parameter by using the length function and assign the value to the length variable. With the help of the if statement, we will check if length equals to 0. As it does not, we will not print 0 in our console, but move to the else statement, which will display a tuple data type of IM in our console. In this lecture, we are going to build our own exception from scratch. If we want to create our own exception, we can inherit from a specialized exception. However, it will be closely connected to Python built-in exception tree. If we want to inherit from our own hierarchy and don't want it to be closely associated with Python exception tree, we need to derive it from exception classes like general exception. So we will use the general exception as the base class, as our own exception will be derived from here. Our exception will be equipped with specific information. Our first exception class will be called warning EX and will inherit from a general exception. Constructor will contain two predefined parameters along with a self parameter. We will access the exception class constructor and update it with the announcement parameter. Our class will also contain an instance variable called name, to which a name parameter be assigned to. So we have just created our own exception. We will create one more exception called error EXC. However, this time warning EX exception will serve as its superclass. Constructor will contain three parameters as well as the self parameter. We will also access our superclass's constructor in order to override and update its values. An instance variable called date will be a part of our exception, to which the date parameter will be assigned to. We will create a function called call_a with a name parameter. We will use two if statements. The first if statement will ask if name parameter equals to string data type of warning EX we should raise warning EX exception as well as pass two arguments. As you are well aware of the fact, when the raised instruction is placed next to the exception class, a class is instantiated, an object is created. Therefore, the arguments will be passed to the name and announcement parameters of the warning EX class. We will do the same when the name parameter equals to error EXC. Create an object and send the arguments to the constructor of the EXC class. We will use the for loop to loop through a list data type containing two string elements, and use the try_except block to invoke the function as well as handle an exception. As we run the following code, the temporary X variable will be assigned the warning EX string data type. We will invoke the call A function inside our try statement by placing X as an argument. As a result, the name parameter of our call A function will receive a value of warning EX string. The if statement will check if name parameter equals to warning EX. Since it does, we will raise the warning EX exception. Our except block of warning EX should handle it, which we have captured as an object and given it an alias of we. When we use the print function to print the object itself, we will have this is warning with exclamation points appear in our console. Then we will have a colon appear in our console on the same line, and finally we will access the name instance variable of our exception, so we will have warning EX appear as well. We will loop one more time. This time the X variable will receive a string data type of error EXC. We will invoke the call A function inside our try statement. Name parameter will be assigned error EXC string. We will move to the second if statement as the name parameter does not equal to the warning EX string data type in the first if statement. We will raise the exception of the error EXC as the name parameter does indeed equal to error EXC string data type. We will handle the raised exception with the except block of error EXC, which we have captured as an object and given an alias of EX. The print function will display three arguments. First, we will have triple error appear in our console, then a colon, and finally, as we have accessed the date instance variable of our exception class, we will have integer of 2024 appear in our console as well. In this lecture, we will cover more advanced concepts of exceptions. We can get additional information regarding an exception object by using attributes such as name and path. I will use the following practical example to showcase their functionalities. Inside our try block, we will use the import keyword to import a specific module called file. As such module does not exist, we will use the except block to handle the raised exception with import error exception, which will be captured as an object and given an alias of IE. We will first apply the name attribute to our exception object and place it as an argument inside the print function. As a result, we will have file displayed in our console. The name attribute displays the name of the module which we have attempted to import. We will use the print function again, but this time apply the path attribute to our exception object and place it as an argument. As a result, we will have none appear in our console as a result. The path attribute displays the path to the file which caused the exception. We can also get none as a result, which was the case here. There are more attributes that are available and can be used on an exception object. However, certain attributes can only be applied on a specific exception object. Here's a list of attributes we can use on a Unicode error exception object. Unicode error exception is a subclass of the value error exception. Therefore, all the listed attributes are accessible to the value error exception as well. The Unicode error exception is raised when Unicode-related encoding or decoding error occurs. So first, we will try to decode the string code point inside the try block using the decode method, which will raise an exception. We will handle the raise exception with a Unicode error exception inside the except block and capture it as an object and give it an alias of UE. First attribute applied on the exception object will be the encoding attribute. As a result, the print function will display UTF-8 in our console. The encoding attribute displays the name of the encoding that raised the error, which in our case was the UTF-8, which we have indicated in the decode method. The next attribute we will use is called reason. The reason attribute will simply describe the reason behind the error in a string format. So as a result, the print function will display invalid start byte message in our console. When object attribute is applied on our exception object, we will have the following message displayed in our console. As the object attribute displays the name of the object the codec was attempting to encode or decode in our case. And finally, we will use two more attributes called start and end, and use the print function to display the result. So by using the start attribute, we will have integer 0 appear in our console, and by using the end attribute, we will have integer 1 appear in our console. The start attribute displays the first index of the invalid data in the object, while the end attribute indicates the index of the last invalid data of the object. In this lecture, we will discuss an interesting concept called chained exceptions. The exception chaining feature is utilized to effectively deal with an additional exception that we have indirectly or directly raised while dealing with another exception. When an additional exception is indirectly raised while dealing with the first one, it is an example of implicit chaining. When we are to knowingly raise another exception while handling the first one, such case is referred to as explicit chaining. In both cases of implicit and explicit chaining, an information about the previous exception will not be lost. We are introduced to two attributes with chaining concept. We have the context attribute, which is inherent for implicitly chained exceptions, while another attribute called cause, which is an attribute for explicitly chained exceptions. By using these two attributes, we are able to keep a reference to the original exception object for later use. We will use the following practical example to implicitly cause an exception. As we run the following code, an interesting message should appear in our console, such as during handling of the above exception, another exception occurred. So as you can see at the code here, while trying to handle the indexing error exception with the general exception itself, inside the except block, we have placed the print function, and inside the parentheses, we have placed integer 1 divided by 0. As a result, we have caused another exception. So again, this is an example of chained exception. While dealing with the first exception, in our case the index error, we have raised another exception, zero division error. So a chain exception has occurred in this code. Through this practical example, you will see and understand the workings of the context attribute. First, an exception will be raised due to the incorrect indexing. We will use general exception to handle the error and capture it as an object. We will place a try except block inside our except block to print another data and handle any potential exception. We will cause a zero division error by trying to divide integer 1 by integer 0. Use the zero division error exception to handle the exception itself and capture it as an object. First, we'll print the outer exception object. So we will have least index out of range message appear in our console. Then we'll print the inner exception object. So we will get division by 0 message in our console. Now we will apply the context attribute on our inner exception object. As a result, with the help of the print function, we will get a message of least index out of range in our console. So as you can see, the information about the original exception was not lost and is referenced by the context attribute. Now we will concentrate on the cause attribute. We'll create our own exception first. We'll use the try block to access a specific element at index 2, which of course will raise an error. We'll use the index error exception to handle the error and capture it as an object. Now, we will intentionally cause an exception by writing the following line of code. We will place the entire code inside a function called check. So we will use the try except block to invoke the function and handle the potential error. So when we run the code and invoke the function, we will handle the exception with our personal exception and capture it as an object. Then we will use the print function and utilize formatting. So as a result, we will have exception, new error was raised due to least index out of range. So we have applied the cause attribute on our exception object. So we have received least index out of range message in our console along with exception, new error, as we have first captured the object and labeled it NE. So if we fail to handle the subsequent exception, which we have explicitly raised, we will have a message appear in our console of the above exception was the direct cause of the following exception message appear in our console. As by writing the following line of code, we have tried to raise an exception explicitly from original exception object. The final attribute I would like to talk about that is closely associated with exceptions is called traceback. Unlike the other attributes, each and every exception object owns a traceback attribute, so we can apply it to every object. I will update the previous code by incorporating the traceback attribute. Using the traceback attribute, we are able to trace an error as well as the function calls made in our code. And in the following lecture, I will also use the traceback module to get a more detailed explanation of some of the errors that were raised in our code at some points. First, we'll create our own exception, then create a two-element data type, list data type, use try except block inside our function to raise original index error exception, and while trying to handle the raised exception, we will explicitly raise another exception by placing the following line of code. So when we invoke the function by using the try block inside the function, index error will be raised and handled by the index error exception in the except block, and of course capture it as an object. However, we will raise additional exception by writing the following line of code. Outside the function, we will use the except block and handle it with our own exception, which will be captured as an object as well. First, we will apply the traceback attribute. As a result, we will get the following message appear in our console, which is the number of the memory point where our traceback object is located at. We will use the type function and apply it on our exception along with the traceback attribute. As a result, we will get class traceback message in our console. In this lecture, I will use a module called traceback and use its method called format_tb to get more details about the exception that will occur in our code. We will update the previous code by first importing the traceback module. We will use a method called format_tb, which will get us a list of strings describing at what point our code broke down and raised an exception. Since the method returns a list, we will assign it to a variable and use a join method to combine a new line character with a variable data. So instead of the entire data being on one line, each string will appear in a new line. So when we run the following code, we will get the following message appear in our console. The first line is due to us applying the traceback attribute on the object. The second result appears as we have used the type function. And finally, we got the following lines displayed in our console as we have used the format_tb method. It states that at line 15, an exception was raised when we have tried to invoke our check function. And another error was raised at line 10th when we have explicitly tried to raise an exception from index error exception object. And we will print check is complete in our console as well. As you can see, we have managed to smoothly run our code without our code being terminated.